Okay, so the place that I always start with a rate problem, so I always start by writing out like what the generic rate law is going to be for this, like just with powers in places. All right, so I know that the rate law is going to be rate equals some constant k, the rate constant, and in this case it's concentration of H2 to the x, some variable, times concentration of C2H2 to some other variable. Okay, so now like my job is really just to find what these variables are, and let's see if we can just kind of logic this out. All right, to find H2, I'm going to look at 1 and 2 because C2H2 doesn't change, and as I double the concentration, the rate doubles. So that's really like 2 equals 2 to the x equals 1. Okay, so that's directly proportional. So rate is directly proportional to H2. That's great. And then C2H2, we're going to use, I guess, 1 and 3. Okay, and if you double the concentration of this is good. If you double the concentration of C2H2, it has no effect on the rate of the reaction. Okay? Which means that really, like if I take the ratio of these two, I get 1 equals 2 to the y. So what does y equal? What, if you take any number and you raise it to what power do you get 1? Well, y is 0. Okay. So that's the sort of logicking out bit. If you want to do the nitty-gritty math, I'm going to show you how to do that now. Okay, and it takes a while. All right. So I'm going to do the same thing, right? I know that I'm going to compare rate 2 to rate 1. Well, I know that rate 2 is k times the concentration of H2 in 2 to the x times the concentration of C2H2 in 2 to the y. Now you might be asking me, why am I putting rate 2 on top? Okay, always put the bigger rate on top. Okay, some of us are pretty good with fractions, but for a lot of people, I think it's easier to see that 2 squared is 4. Or let's say, and here, I'll erase this just to make this interesting. Okay, I think a lot of people are much more comfortable saying 2 to the third power would be 8, more so than saying 1/2 to the third power would be 1/8. Okay, so if you keep the bigger rate on top, then you're always going to have whole numbers rather than fractions. Okay, and these subscripts here just indicate which rate, which equation I'm talking about. And I can say the same thing in bottom, because I know that the rate equals all this stuff. K over H2 and 1 to the x, C2H2 and y of 1. Okay, now let's go through. All right, let's simplify. I know that the k's are going to cancel out because they're the same. H2's are not going to cancel out. They are not the same. And this C2H2, concentration of C2H2 between 1 and 2 doesn't change. Okay, so these are going to go away as well. Yay! Which means that I'm left with H2, concentration of H2 and 2 to the x over concentration of H2, 1 to the x. Now, hopefully, you remember that if you have something like 3 to the x over 2 to the x, you can simplify that by saying it's 3/2 all raised to the power of x. Okay? Hopefully you remember that from algebra. So what I can really say is that rate 2, I'm pulling everything together here, rate 2 over rate 1 equals concentration of H2 in the second one over concentration of H2 in the first one, all of this raised to the x power. Okay, now I can plug in numbers. So this is 3.0 times 10 to the minus 4. And the rate in this one is moles over liters times minutes. Moles over liters times minutes. And 1.5 times 10 to the minus 4 moles over liters times minutes equals concentration of H2, 0.40 molar over 0.20 molar. All of this raised to the power of x. All right, my units cancel out in here. My units go away over here. The 10 to the fourths go away, so this is really 3.0 divided by 1.5, which you should realize is 2. And this is 0.40 divided by 0.20, which is 2. 2 equals 2 to the x. Okay, now notice that this isn't 2 equals 2x. All right, it is not 2 equals 2x. People mess that up all the time. Okay, make sure that you remember that we're talking about powers. These are orders, okay? So x then has to be equal to 1. And for the most part, I'm going to assume that you know 2 to the 1, 2 to the 2, 2 to the 3, maybe 2 to the 4, and 3 to the 1, 3 to the 2, 3 to the 3. Okay? I'm not going to do weird numbers here because we're not super confident with logs at this point. So, yeah, you should be able to just look at these and figure them out. As long as you remember that we're talking about powers and not multiplication. All right, now let's go back and let's now figure out why. Okay, so I'd set this up the same way. Except for this time, I'd take rate 3 divided by rate 1. Equals, okay. So this time, I know that the k's are still going to cancel out, right? I'm going to set this up very similar. The k's are going to cancel out, and between 3 and 1, this time, the H2s are going to cancel out. So all I'm going to end up with is this stuff. Okay, concentration of C2H2 of 3 over concentration of C2H2 in 1. And this is all raised to the power of y. Okay, and if you're having a hard time figuring this out, go back and watch how I did it with the H2. All right, so now when I plug values in, and I'm going to skip the units because the units all cancel. 1.5 times 10 to the minus 4 over 1.5 times 10 to the minus 4 equals 0.40 divided by 0.20 raised to the power of y. And this is 1 equals 2 to the y, so y equals 0. Okay? So when we put this all together, if I take my x and y and I plug it back into my rate law, I say rate equals k times the concentration of H2 to the 1 times concentration of C2H2 to the 0. Now keep in mind that C2H2 raised to the power of 0, no matter what value this is always 1. So rate equals K times the concentration of H2. All right, now pause at this point and see if you can get me a value for the rate constant with correct units. All right, so I'm just going to pick the first experiment. And in this case, K equals rate over concentration of H2. So from the first experiment, that's 1.5 moles over liters times minutes. And concentration of H2, oh boy, they didn't put them in, but this is moles per liter. This is moles per liter. Oy, 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 oy. Okay. Well, let's do units first. Moles over liters. Okay, moles cancel out, liters cancel out, and I get 1 over minutes. Okay. I'm just doing. Now if I plug in numbers, 1.5 times 10 to the minus 4 divided by concentration of H2 is 0.20. And when I plug that into my calculator, I get 7.5 times 10 to the minus 4. Okay, my unit is 1 over minutes. Good job.